First of all, I have here data file in .xlsx format. It's a worksheet, and I have here on my left here the description of the activity. This is just a hypothetical activity, and there's a code here and the predecessors, and this is here is the most optimistic days on how long will activities will be finished, and this is the most likely amount of days the activity will be finished, and this is the pessimistic view on how many days activity will be finished. Now I have some a previous video about how to compute the critical path method, but in this case, I'm going to include the PERT part, or the programmable program evaluation review technique part, wherein we are excuse me, we are given these three likely days, and we need to compute for exactly how much days will it take here. So the software will be getting this data from the description up to the pessimistic days, and then it will compute for days, number of days, early start, early finish for the forward pass, latest start and latest finish for the backward pass, and the slack, and it will tell us if it's critical or not. So the program will obtain this data, load this data into Python, compute it, and provide an output. So this is the input, the loaded data here, as you shown in the Excel file, and then the results after processing are this one. Okay, then the results are being processed in PERT-CPM.xlsx. So now we're going to check in. We're going to use this Jupyter notebook so that it will be much more clearer, step by step, in how I made it. So first of all, in this first step, I just import all the necessary libraries. This is a regular expression library, the pandas libraries, the OS library, and the NumPy library. After I imported them, I first define the class. The plan is that to make a class on this particular activities. So activity A is one class, or one object of a class, which has these properties, predecessors, and these numbers, activity B, and so on and so forth. So to define the class object name task, I just make it here, and this put in some variables. It will take some inputs like description, activity, predecessors, and days. Actually, these are the input from the Excel file, but this one, this is the input from the manipulation later on. So the object will get these four variables and store it here, define and store it here, and we also need to define some variables. These variables are needed during computation. We have also one function like the compute slack. Upon obtaining the latest finish values and the earliest finish values, we just need to take the difference of the two, and that is the slack. If there is a slack, if it's greater than zero, then there's extra days that the job will be okay to be delayed. So it's not the critical, and it will be critical if the job needs to be finished on time or less than that that days of that days. So now in this function, I defined the read data. This is where we read the Excel file. So it requires the name of the Excel file. In this case, the name of our Excel file is data.xlsx. By the way, I'm using LibreOffice, but it is the data file can also be used in Excel because it's an Excel format, that XLXX. Then the sheet name again is this one, so sheet 1. So we put in the Excel file and the sheet name, and it will process by using the pandas libraries, read at Excel, and then it will return a data frame. In this next function, this is for compute for days of the task or the activity. It is just like this again. We need to compute for these days, so we need the inputs of these three, and we're going to compute the days. So now the my data days, or the my data is a data frame we obtain from reading it from the Excel file, and then we put in one column, additional column, which is days. Although it's already existing, we can overwrite it, and we put in this command numpy ceiling. So if there's days are in fraction, so we just round it up to the rounded up upwards. So if it's the days 3.2, we make it 4. So the optimal days plus the most multiplied by 4, most likely multiplied by 4, and the pessimistic days, and we divide them by 6. And we return my data. We return my data with already days included in it, with the data in them, computed data in them. Okay. And next, this is the function to create the task object. So we already defined the task class, right? This one here. Okay. Now we're going to use the task class by defining a function create task. So there's a list of task objects, and we're going to make a loop on that list. So it will check the length of the my data. So in this case, this is the length of my data from 2 to 9. Okay, it will compute that length. Okay, so that is how many objects are there inside of this. So task object that appends. So this is a task class, and it will get 4 variables: the description, the activity, the predecessors, and my data days, which is described here in initialization. Next is that we're going to return a list of tasks named task object. Upon getting those task object list, we're now going to do the forward pass. Take note that we already finished computing for the days. We already finished computing for the days, so the days is here. Now next we're going to compute the early start and the early finish of the forward pass. To compute for the early start, those activities which has no predecessors as automatically has the early start of 0, and those which has some predecessors, their activity should start after those their predecessors has already been finished. So to compute for the forward task, we iterate on the task object, a list of tasks here, and then we check if the type of the task predecessor is type string. So in this case, these are type strings, but these are not. So if they are type strings, so it will process this task. If not, so it means to say that there's there's no predecessors, so their early start is automatically 0, like this. No predecessor, early start is 0. If there are predecessors, so you're going to check for the predecessors. You're going to take the predecessors of the task, okay, and then it will store the earliest finish of all the task predecessors here, okay. So I mean to say, if there is two predecessors or one predecessor, the early finish of each individual task predecessors of this task, okay, so these are the predecessors of this task, for example, the earliest finish of A and B will be obtained, and then get the maximum of the two. That will be the early start of the task A, task C. So like for example, this one 6 and 9, the maximum earliest finish is 9, so 9 will be the early start. So that is how it is here. So we store individual predecessors, okay, and in this loop, individual predecessors, task that predecessors, okay, so they will check what activity is that. For example, task as predecessor is A, so they will check the activity is A, then it will append, put it here, the earliest finish. So they will put the earliest finish 6 and 9. So they will check what is here, what is the predecessor, and the program will go to the activity, and then it will check the earliest finish and put it in a list. Earliest finish here, the list here, and then it will take the maximum of the two. If then that will the maximum of the two will be the early start. In any case, if its early start is or zero, or if it's the maximum of the earliest finish of the previous predecessor or the predecessor task, it's common that the task at earliest finish is equal to the, the task of the early start plus task days. So the earliest finish of that particular task is we need to add the summation of the early start and the task days. So what this means to say is that upon getting the earliest finish of their predecessors like this one, so it's 9, you need to add the days in order to obtain its earliest finish, which is 19. So that is how we compute the forward pass. So the forward pass, in forward pass, I'm going to finish having the early start and the early finish like this. Next, we're going to do the backward pass. In the backward pass, there are also some rules. First rule is that the latest finish of the activity, which is not a predecessor of any activity, is the maximum earliest finish. Okay. Rule number 2, the latest finish of an activity, which is a predecessor of any activity, is the minimum earliest finish of its successors. And the latest start of an activity is the latest finish less the activity time. So we're going to do go with these three one by one. First, we need to make a list of the predecessor and the early finish. Before we do the backward pass, we must need first to get these predecessors. Okay, because the idea is that for those tasks that has not which is not included in the predecessor list, like H and G, their maximum late finish, their late finish actually is equal to the maximum early finish. The maximum early finish of all tasks is 42. So those tasks which has no predecessors, which are not predecessors of some of the tasks, it means to say that they are not successors. Like for example here, H and G has no successors, and no task has having H and G as their predecessors. Okay, so in that case, the maximum earliest finish is the late finish of those tasks. So here, so in this loop, of course, we need to take again the predecessors as string because some predecessors are null, and afterwards we check in for the task predecessors in each task. Okay, and we check individually. and we append the predecessor list. So it means to say that we are just we are just getting this again, this whole predecessor list, and put it here. And then we also need to fill in the successor variable in the class. So if m that activity, so the activity is equal to j, so we need to access to append the successors. Okay, so that is how it is, because we have this m activity is this one activity list. If it is in j here, okay, then it will be part of the successor list. Okay, so the successor again are these tasks. For example, the successor of task f is g and h. Okay, g and h. So g and h is successor of f. So the successor list of f includes g and h. The successor list of a is c. The successor list of b is c. And the successor list of c is both d and e. So we're going to do that in this loop. After that, we append the task that earliest finish. Okay, so the task that earliest finish, we're going to put it in here. So in this case, whatever is that going, like for example, this 142 is the earliest finish. The EF, we're going to get this maximum of this, and we're going to put it here. So that's why here success, what you call this, here we're going to append the earliest finish. The loop the loop of this one does not include the EF append because it's automatic that it will append the earliest finish. But the loop of these two, we get the predecessor list and the EF. EF is also the list. Why do we need these two? Because of this. This is the loop of the backward pass. In the loop of the backward pass, we already have the EF because the EF is already been filled up here. EF is already been filled up here in the process, right? In this task that earliest finish, it's already been included here in the EF. So EF is already have the list of this one. So the maximum EF is if the task activity not in predecessors, so it means to say that it is not it's not in predecessor. It is no task has predecessors of this one. Like for example, GNH, you cannot find GNH in the predecessor list. So GNH latest finish is the maximum early finish. So GNH latest finish here one is the maximum early finish, which is 42 there. Else, if they are inside the predecessor list, so here it is. We need to make a small list of minimum latest start, and that we're going to check the tasks. We already have these successors. We already fill up the successor list here. So for X in task the successors, then for T in task object, if T the activity is equal to X, so we're going to say it's there, then we will append it with minimum latest start with the latest start. So what it means to say is that we need to get the latest start. For example, F, we need to get the latest start. of G and H, and the minimum of this G and H will be the latest finish of F. Like for example, latest start of G and H is 37, 34. The minimum of the two is 34, so that will be the latest finish. And common for both tasks, if you already have the latest finish, you just need to subtract the days. So that is how it is. Next is that we're going to compute for the slack. In this function, we just need to take the function for each task in task object. So we need to get the class function compute slack and activate it. There's no, because the two are already there. The here here latest finish and the earliest finish are already been computed in the forward and the backward pass. So you just need to compute it. Next is this one. It's just to update the data frame. So update the data frame with the data frame and the task objects, and we just make the second data frame df2 and put here some data from the data frame and put in new data from the task objects. Task object is a list. It's the list of tasks. So the list of the task in the list of task object has some data variables like early start, earliest finish that we compute earlier. So we just make it in series and put it in a column and everything. Now here's a function main. This is actually the one that we're going to put all we put everything, we put all in all together. This is what links every function so that the program will run. So in the first line of main function, we have here the PD, the set option. It's just this we need to display the whole table in one line. Like for example, one whole like this, and not there's no more the column on below. So we just hold one line. Next is just need to clear in the terminal command line. So first of all, we're going to read again. This is the first step. Read the data. We already defined this function, and it will return a data frame in pandas. Next, we're going to print that loaded data and print the data frame. So in this case, the data has been loaded, and this is the data frame that was printed. This is the output. So in this data frame input, there's just this again, and there's no computation on this side. Okay. Next is that compute for the days of the task. So we need to compute for the days. So we start computing these days because days is here is none. So computing these days. Next is create the individual task by running the function create task. Afterwards, we compute for the critical path. So the output of this is a task object. So the task object, we make it here, make it as an input on the function forward pass. Okay, and next we do the backward pass. It doesn't return anything because the forward pass will compute and put inside the task in the task object list the values. Then we make the backward pass. Afterward, we compute the slack. After that, we need to update the data frame like this function. We call again this function, and then print the results here. Print out the results here, one line, and then we print the final data frame. This is the final data frame with the values. Okay, and we execute the function final df to Excel. So this is a pandas function to save the data frame into a PERT-CPM.slx6 file with index equals to false. This is false because there will be a column. If this is true, there will be a column with the index there, but it will be ugly, so I make it false. Next, in order to run the program, we just need to put in main here. So the output is this one. Again, the same as the command line. So the loaded data is here, and the output is here. So if you're going to interpret the output, the first activity has slack, three days slack. It means to say that even if you make this activity, like you do this most likely seven days or 8 days, it will not affect the finish time of the project, which is 42 days. The project will be finished in 42 days, so it will not be affected. If there's a slack, you can have a 3-day leeway, but the rest is the critical path. So the critical path is B, C, D, F, H. So the critical path is B, C, D, F, H. So this should be finished on time or below its designated time allowance, so that the project will not be extended more than 42 days. Okay, so that is how I automate the PERT CPM using Python 3.